Hi everyone, I welcome to this session about discontinuity. This is one of the main important concept in real analysis, and this is GOKILA, Assistant Professor, Department of Mathematics, Trinity College for Women, Namakkal. So before going to the topic, first we discuss about the concept continuous. The first definition is continuity of a function at a point. A function f is said to be continuous at a point x is equal to a if the following three conditions are satisfied. First one, f of x is defined, that is exists at s is equal to a. Second point, the limit of f of x as x approaches a exists. And third one, the limit of f of x as x approaches a is equal to f of a. So these are the three conditions for the function f is continuous at the point x is equal to a. Now we have to say the another definition or concept of continuous. That means it is clear that any point x of open interval a comma b limit t tends to x f of t exists if and only if f of x plus is equal to f of x minus is equal to limit t tends to x f of t. So this is the one of the limit concept of continuous. Now let us see the example. Consider the function f of x is equal to root of 4x plus 1. Show that f is continuous at 2. Solution: by using the concept of limit continuous, limit t tends to x f of t is equal to limit x tends to 2 root of 4x plus 1, which is equal to root of limit x tends to 2 4x plus 1. So apply the x value by 2. After calculating, we have the value 3. So this is the limit value of f. Therefore, we say that f is continuous at 2. The same concept is explained by the graphical method. In this first figure, we can draw a graph without taking hand. That's why we say the continuous function can be drawn with a single or unbroken pencil stroke. That means no breaks in the graph. Note, a polynomial function is continuous at every real number. Further, consider the function f of x is equal to x cube minus x. In the second figure, the graph is going on upward and also downward direction infinitely. Here there is no break, so that it is continuous on open interval minus infinity comma plus infinity. Second point, a rational function is continuous at every real number in its domain. Further, consider the function f of x is equal to 1 by x. In this third figure, the graph is going on continuously in which does not meet the origin, so that it is continuous on the domain my open interval minus infinity comma 0 union open interval 0 comma infinity. Now let us see the second definition, discontinuities. Let f be defined on open interval a comma b. If f is discontinuous at a point x, and if f of x plus and f of x minus exist, then the first point f is said to have a discontinuity of a first kind or a simple discontinuity, either f of x plus not equal to f of x minus or f of x plus is equal to f of x minus which is not equal to f of x. Otherwise, neither f of x plus nor f of x minus exist. Second one, in this case, the discontinuity is said to be of the second kind. So, these are the two kinds of discontinuity. Here, f of x plus denotes the right hand limit of f at x and f of x minus denotes the left hand limit of f at x. Now, let us see the example 1. Let us consider the function f of x is equal to double interval function. First interval, if 0 less than or equal to x less than or equal to 1, the function is x squared. And the second interval, 1 less than x less than or equal to 2, the function is 2x, at which the point f is continuous. Solution: in this example, we have the interval, closed interval 0, 2. So we have to calculate at x is equal to 1. The definition of the continuous function is limit x tends to a f of x is equal to f of a. Now we have to check the continuity at x is equal to 1. That is, limit x tends to 1 minus f of x is equal to limit x tends to 1 minus, apply the first function x squared, which is equal to 1 squared equal to 1. Next, limit x tends to 1 plus f of x, which is equal to limit x tends to 1 plus, apply the second function 2x, which is equal to 2 into 1, which is equal to 2. But here we have the two different limits. But already we know the limit is always unique. So f has no limit at x is equal to 1. Therefore, f is not continuous at x is equal to 1. Now, let us see the example 2. Define the function f of x is equal to x plus 2 if minus 3 less than x less than minus 2. Second one, minus x minus 2 if minus 2 less than or equal to x less than 2. And third one, x plus 2 if 0 less than or equal to x less than 1. Solution. Here, first we have to check the continuous at x is equal to minus 2 because here the total interval is open interval minus 3 comma 1. So first we have to calculate limit extends to minus 2 f of x which is equal to f of minus 2. Apply the x value by minus 2 in this given function when x is equal to 2 is in the second interval. So we use the second function which is equal to minus of minus 2 minus 2 which is equal to 2 minus 2 which is equal to 0. Second, we calculate limit extends to minus 2 minus f of x is nothing but the left hand limit value of minus 2. So we use the first function that is x plus 2 which is equal to minus 2 plus 2 which is equal to 0. Third, we have to calculate limit extends to minus 2 f of minus 2 plus f of x is nothing but the right hand limit value of minus 2. So that we use the second function that is minus x minus 2 which is equal to minus of minus 2 minus 2 which is equal to 2 minus 2 which is equal to 0. So above the three values we have the result limit extends to minus 2 f of x is equal to limit extends to minus 2 minus f of x which is equal to limit extends to minus 2 plus f of x. So we have the result f is continuous at x is equal to minus 2. Now, next we have to check the continuous function at x is equal to 0. So, in a similar way that we have to limit value, limit extends to 0 f of x is equal to f of 0 which is equal to 0 plus 2 which is equal to 2. Next, limit extends to 0 minus f of x is equal to minus 0 minus 2 which is equal to minus 2. And third one, limit extends to 0 plus f of x is equal to 0 plus 2 which is equal to 2. So, we have the result limit extends to 0 minus f of x is not equal to limit extends to 0 plus f of x. Hence, f has a simple discontinuity at x is equal to 0. Hence, we say that f has a simple discontinuity at x is equal to 0 and it is continuous at every other point of minus 3 comma 1. Thank you.